So in the first part we have discussed about some basic theory about your perturbation theory, and then we discussed about these formulas, right? And then we did two problems. So now today in this second part I'll be doing some around 5 problems, right? So before we move to those problems, let us just recapitulate these formulas. So first is this is the ground state first order correction to the ground state energy. This is the first order correction to the nth eigenfunction, and this is the second order correction to your nth eigenvalue, right? Now the prerequisites, I mean before I start doing the problems, what I need to know is I need to obviously know these formulas, as well as I need to know the exact solutions for different potentials, right? So if I am doing a problem relating to your infinite square wave, so I need to know what is psi n0, right, which is square root of 2 by a sin n by x by a, that I need to know. I need to know En0, the energy eigenvalues, which is n square, pi square, h square by twice m square, right? And also while doing the problems, I need to know this, right, which is the gamma functions. Okay, so now let us move to the first problem. So the first problem says that I've been given a potential, right, which looks like this. This actually is an infinite square wave potential if I do not have these epsilon terms here, right? So this is the infinite square wave potential. So the question asks me whether the ground state energy, after the perturbation is added, what will happen to the ground state energy, whether it is going to increase by epsilon, whether it is going to decrease by epsilon, whether it is going to increase by epsilon square, or whether it is going to decrease by epsilon square, right? So what I need to do is, so in the first part I had done two problems wherein my infinite square wave potential was raised by height V0, right? It was raised by height V0, and hence my correction came out to be En0, which is the known part, plus V0, right? And when I had the similar thing, but it was raised by height V0 between 0 to a by 2, then my correction came out to be V0 by 2, right? So keeping this thing in mind, so I will be solving this problem. So I can make use of the formula, right, En1, En2, and then do my problem. But considering the fact that we have done for a constant potential, and then we saw that the energy is either lifted up or decreased, so hence for En1, which is the first order correction, the contribution from this part is going to cancel out with this part, right? So hence the first order correction is 0, right? So if my En is the total one, then I have my En0, the known part, right, for the infinite square wave, En1, which came out to be 0. Now let us check En2. Now when I am seeing that my En1 came out to be 0, that means my terms with epsilon has cancelled, because En1 is actually the term which is going to contain parts like this, right? So here I should be writing the perturbation, and here the perturbation is of the order of epsilon. So these two options are ruled out. So I should be focusing on these two, right? Okay. So I need not solve the whole problem, right? Because it just asks me whether it increases or decreases, right? So En2, if I see from the formula, so I am calculating for the ground state, right? So this is the ground state correction. So E0, right? So here I am actually calculating for the ground state, right? So I can write this to be 0, right? Because it asks me, the questions will be given in the description box, but for now just understand the question has been asked for the ground state. What will happen to the ground state, right? So E02 is given by using that formula. M is not equal to N, meaning M should not be equal to 0, right? And you have your psi M, right, which is 0 H prime psi N, because I am doing for the ground state, hence 0 whole square divided by E N is 0, E N. Okay. Now this is h prime and our perturbation is of the order of epsilon, right? So if I put epsilon here, right, I mean I should be getting two terms, right? So if I put epsilon here, that means epsilon squared, right? So I mean my correction, this E02 correction is of the order of epsilon squared, but I do not know whether it is increased or decreased, right? To identify that, let us move one step forward, and that is, let's see for this one. So E0, right? So E0 is going to be, so E0 meaning n equals to 1, right? The ground state energy. It is pi square h cut square by twice m square, and m should not be equal to 0, right? So I should be using something else apart from 0. So that could be, say, E10, which comes out to be n square, right? So that means for first excited state it should be 2, right? So 2 squares. So hence 4 pi square h cut square by twice m square, right? So I see that this term is more than this term. So that means this EM0 will always be greater than E00. Hence, this term comes out to be negative because of this, right? So because it comes out to be negative, and it is of the order of epsilon square. Hence, the correct option is your, after the addition of perturbation, my ground state energy decreases by the order of epsilon square. There is no correction, I mean the first order correction is not there. My second order correction exists, right? And it has been decreased by the order of epsilon square. Okay, so that is your first problem. Now, let us move into second problem. Okay, the second problem here is to do with this, right? So this is the second problem. So it is half m omega square x square minus a x, right? So what do I understand from this? What is the perturbation? See, I can always go ahead, I mean this actually is your m omega square x square minus a x, right? This is something which we already know, that is your harmonic oscillator, right? For which the energy eigenvalue is given by, that means the 0th order correction or the exact one is given by n plus half h cut omega. Now I need to know what this term is going to do. I can go ahead and then do this, right? In this question it actually asks me what is En1. Okay. So to find that, I can go ahead and use this, right? But from the first part, I know that if I have some constant potential, right, then I can, I mean like either the potential, the final energy is raised or lower. So I will try to include that concept over here. So how do I do it? Let me say my V of x is half m omega square, and then I take a common, which gives me twice a by m omega square x, right? So I will just try to make it as whole square, which gives me x square minus twice into x into a by m omega square, right, plus a by m omega square whole square minus a square by a by m omega square whole square, right? So this is what I get, right? So from here I can write that this is equal to, the first one is x square, I mean it is of the form a square minus 2ab plus b square, right? So I basically added and subtracted this term. So that gives me x minus a by m omega square whole square, right? And then a term which consists of twice 1 by 2 m omega square a by m omega square whole square, right? So that means I have got half m omega square x minus a by m omega square whole square minus, so my mm cancels, so it is a square by twice m omega square, right? So I've got half m, so that is m omega square, right? So that simply meaning I know what is the eigenvalue for this half m omega square x square, right? I know for that. So my total En is En0, right? En0 plus En1, the first order correction. I know this, which is n plus half h cut omega, and then I know En1, which is minus half a square by twice m omega square. So this is my correction, the first order correction to this perturbation. This particular perturbation is minus a square by twice m omega square. Okay, I think this is clear. Now let us move into the third problem, which is similar to the second, right? Which is very much similar to the second one. So the third problem is h equals to p square by 2m plus half m omega square x square plus lambda x, right? So this questions, what I have to find here is, so this is the perturbation here, right? I need to find the difference between energies of the first two levels. So that means I have to find my new En, right? And then whatever my new En comes, then I have to find the difference between this E1, the one which I have calculated from here, and E0, that I have to write. Okay. Now, just now I have done similar problem related to this, which was I just expanded this part, right? Made a whole square and there was some constant left. So that came out to be n plus half h cut omega, right? And it comes out to be lambda by twice m omega square. So this is what we get, right? So this is the first order correction. So you can just do whatever was done in your second problem and then come out to be this. Okay. Now E1 here is, for this part it is half h cut. So E1 here is half h cut omega minus lambda by twice m omega square, right? And E0, this is 3 by 2, right? Because E1, so 1 plus 1 is half. And E0 is half h cut omega minus lambda by twice m omega square. Right, so the difference between these two energies is asked. So delta E. So these two terms are going to get cancelled, which is E1 minus E0. So that finally gives me h cut omega. Right. So these are the ones where there was, just the energy eigenvalues had just been lifted or decreased by some constant potential. Right. Okay. Now let us. These kind of things cannot be done for all the problems. So let us see another problem wherein you have been asked, you need to make use of these formulas here. So the potential for that problem is minus delta x. So this is your delta potential problem. And your psi for this is given by A e to the power minus alpha mod x, right? And h prime is given by B x square, right? So what we need to find is, we need to find E0 1. That means the first order correction to the ground state energy. That means I have to find this, right? Because this is the first order correction. Okay. To do that, I need to do, so my E01 is actually equal to psi. So it is E01, so it is psi 0, 0, H prime, psi 0, 0. Okay. Now what I will be doing is, I have to make use of my potential, this perturbation here. So it is A e to the power minus, because psi 0, 0, so twice alpha mod x, right? And then h prime, so which is b x squared dx, right? So this is what I have to find. But I see that this one is not normalized, right? So I have to find the constant a using the normalization. So first I need to find a, which is, I need to do this, which is a square e to the power minus alpha mod x dx equals to 1. So from there, if I do this, I'm going to get my a square to be, a comes out to be square root of alpha from here, right? I mean, this is just normal integration. So it comes out to be root alpha. So using that, right? So if I use it over here, so that means I'll get root alpha, so that means alpha e to the power minus 2 alpha mod x, so this runs from minus infinity to infinity, and my potential, this perturbation bx square dx, right? So this again is a problem of simple integration. I mean, it's a simple integration problem. So what you need to do is, you run it from minus infinity to 0, right? So in that time it will become alpha b minus infinity to 0, so you can write it as e to the power, so it becomes plus, right, because it's a mod. So 2 alpha x square dx, and 0 to infinity, 0 to infinity, the same thing, e to the power minus twice alpha x square dx, right? So now here you have to make, you can, I mean, club these two terms together. Here you have to make use of your gamma functions. That's why I was stressing on, I mean, like knowing the gamma functions integrations, right? So if you do the integrations, the final answer comes out to be b by twice alpha square, right? So these are all simple integrations which I am not doing. If you need, if you want me to solve the whole problem, I could either link the solutions in the description box, or I could make another video on solving the integrations, right? So this is it for your fourth problem. And the fifth problem is a similar one, right, which you all can try. I am just giving you a hint. So b of r is e square by r, right? So minus e square by r. Again here h prime is b x squared psi naught 1 by pi a naught cube e to the power minus r by a naught. Okay. So a hydrogen atom problem is given, right? So you have perturbation bx square. You have your potential. This Coulomb potential is given minus e square by r. What you need to do is, you need to again find your En1. Basically, you have E01. That means the first order correction. The formula to which is given here. Why did I pick up this problem, right? Is because you see here you have r in your wave function, right? But in your potential, because what I am going to be doing is I am going to be calculating this. So that gives me 1 by pi a naught cube e to the power minus twice r by a naught, right? So when I am making use of this, so it becomes b x squared, right? So I cannot be using x over here. So hence what I do is, I take my x, because it's got to do with your spherical coordinates. X, I'm going to take it as r sine theta cos phi, right? So I get it as b will get it as bx square. So r square sine square theta cos square phi, right? Now this is a problem which is got to do with r, theta and phi, hence d3r integration, right? So I cannot be writing this d3r to be 4 by r square dr. You cannot afford to make that mistake, because my theta and phi dependence is still there. Hence what I do is I write r squared sine theta dr d theta d phi, right? Hence I have three integrations wherein my r runs from minus infinity to infinity, your theta runs from 0 to pi, and phi runs from 0 to 2 pi, right? So you can perform the integration, right? So this again is a simple integration, but for r you need to use gamma functions. So the final answer comes out to be something like b a naught square, right? Okay, so this one is for your problem number 5. Thank you.